And Advent Coach just started, but I'm home alone and baby is sad. So, yeah, this will be an interesting one. Day 12, Garden Groups. Why not search for the chief historian near the gardener and his massive farm? There's plenty of food, so the historians grab something to eat while they search. You're about to settle near a complex arrangement of garden plots when some elves ask if you can lend a hand. They'd like to set up fences around each region of garden plots, but they can't figure out how much fence they need to order or how much it will cost. They hand you a map, your puzzle input, of the garden plots. Each garden plot grows only a single type of plant and is indicated by a single letter on your map. When multiple garden plots are growing the same type of plant and are touching horizontally or vertically, they form a region. For example, A, B, 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 C, 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 D, B, B, C, C, E, 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 C. Okay, I probably messed it up. This 4x4 arrangement includes garden plots growing 5 different types of plants, labeled A, B, C, D, and E, each grouped into their own region. In order to accurately calculate the cost of the fence around a single region, you need to know that region's area and perimeter. The area of a region is simply the number of garden plots the region contains. The above maps type A, B, and C plants are each in a region of area 4. The type E plants are in a region of area 3. The type D plants are in a region of area 1. Each garden plot is a square and so has 4 sides. The perimeter of a region is the number of sides of garden plots in a region that do not touch another garden plot in the same region. The type A and C plants are each in an own region with a perimeter 10. The type B and E plants are each in a region with perimeter 8. The lone D plot forms its own region with perimeter 4, visually indicating the size of plots in each region that contribute to the perimeter using minus and the line. The above map's regions perimeters are measured as follows. Okay, so this will be fun. Plants of the same type can appear in multiple separate regions, and regions can even appear within other regions. For example, the above map contains 5 regions, one containing all of 0 garden plots and the other 4 each containing a single X plot. The 4 X regions each have area 1 and perimeter 4. The region containing 21 type 0 is more complicated. In addition to its outer edges, contributing a perimeter of 20, its boundaries with each X region contributes an additional 4 to its perimeter, for a total perimeter of 36. Due to modern business practices, the price of fence required for a region is found by multiplying that region's area by its perimeter. The total price of fencing all regions on a map is found by adding together the price of fence for every region on the map. In the first example, region A has a price 4 times 10, it's 40. Region B has a price 4 times 8, 32. Region C has price 4 times 10, 40. And region D has price 1 times 4, 4. And region E has a price 3 times 8 is 24. So the total price for the first example is 140. In the second example, the region with all of the 0 plants has price 21 times 36, 756. And each of the 4 smaller X regions has price 1 times 4 is 4. For a total price of 772. 7, yeah, plus 4, 4, 4, 4. Here's a larger example. It contains a region R plants with... Okay, I'm not going to read it all. Okay, this will be a little bit more... Yeah, I have not quite understood the question yet. It's also because I need to keep him from crying. So it has a total price of 1930. What is the total price of fencing all regions on your map? Okay, what I will do, I'll read this one more time. I'll put him to sleep. Hopefully it won't take too long. He's kind of looking sleepy. And then I'll start planning things out. Okay, see you in a bit. Okay, so this is what I have. I don't think it's too difficult. So I just wrote down the basic guideline of this function, of this whole challenge. So we need to calculate the total price of fences, and for that we need to calculate the area of the plot of the letter. Then we also need to calculate the sides of each box for the fences. And the total is all plots counted together after doing area times fence. So in here what I will need is a var_l total as well. So yeah, in part 1, I first go over the y of the packed int array, and then I go over x. And if a new letter got found, we send it to the map with the positions. Oh, and that's also something. Change visited land to dot. I don't think there are any dots inside of this. No. I should probably also do this here. Skip dot. So yeah, so we go over everything. If we find a new letter, we send it to the we send the map with position to the count function, which is this here. In here I keep track of the field itself, which character do we need to look for in the surrounding areas. Then we add every field that we went to visited fields, because that will be a valid field. And fields around us that we can still visit will go to visit fields, which I think is probably a wrong way of doing this. Let's see, I think I will need a while loop, so I'll quickly put that here. Well, L to visits is not null. Dot size. Okay, and that's kind of my thinking pattern for this here. I just go over every box that has the same letter. I change the visited land to a dot afterwards, so we don't double check it, and that way I should normally get all areas with their fences. So yeah, let's see. Let's see how this goes. I think in part 2 we will probably need to measure only the fences from like one side and not from the other side. I think that will also be reasonably easy to do by changing everything to a dot. So yeah, let's see how it goes. Okay, and I got my first attempt ready, so I go over the y, the x, I check if there's not a dot, and then I start measuring the lands. This should work, and I'm also doing this to just see if there are any mistakes. I save the first character of the field that I need to check. I add everything to L visit fields, and L2 visit fields I add the position that we start with, because then we enter a while loop, and in this while loop we check for the up, down, left, whoops, and this should be right. And this should normally work. We go over every single field, checking for certain that they are not in L visited fields already, or L to visit fields. If they're not, we append them. Else, we just skip and go to the next one, because we already counted them, there should not be a fence in between them anyway. And then L visited the fields, we append the field that we went to, and then we also remove the field from the L to visit fields. And after that, we change everything to a dot of the places that we've been to. So let's see. So we have result 2174, and we need 1930. Okay, let's see what is going wrong. I see that the E is getting missed for some reason. So I, S, E. The S is getting done, and then the E. Wait, is this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, no, it's just at the bottom. So it is being done, and we should probably, like, just for checking, print an empty string, and let's just copy this to a new function. Func check map. We have done this before already. It's kind of helpful to print out things visually. Ground. Okay. There is a problem. I think it's a problem with left and up. Well, we will never go up, I think. Let's create some extra variables. So var. Okay, so I fixed the function a little bit. So now we have the positions here. Makes the code a little bit shorter. It's still kind of a mess to look at. Yeah. I thought it would look a little bit cleaner. It doesn't. What I do think is I can probably put this into like a separate function, or just go through all the up and down. But yeah, let's see how it goes. Right now, I'm going out of index, and it's going out of index from the F already. So it has to do with the borders, and I think I go out of it. So something is wrong. Also the C, for some reason, it's not counting everything. Somehow. Okay, turns out I'm quite an idiot. It's X, Y and not Y, X. So I just have to turn these all the opposite way, and normally this should work. I always struggle with this. Yeah. Okay, so if I run this, normally the errors should also disappear. We're still getting way too many numbers, so there's still something going wrong. But at least now we have a little bit more correct data to figure out why it's going wrong. So let's quickly get rid of all these things. We don't need those statements anymore, only the print map. So something is going wrong with the map. So we take the R's, we take all the R's, we take the I, we take all the I's. We take the C's, but we don't take all the C's. And it happens when we get to the left one. So with the left one, there's something going wrong. This should be if x is smaller than 0. And if x is smaller than 0, I think. I don't think that makes any oh. Okay. I was just going to say, I was going to say this, it will not be because of this. Oh well, let's use our normal data. I'm still within time. We should probably not print like check the map whenever we use data and instead of test data. And submit, and let's hope. That's the right answer. You're 1 gold star closer to finding the chief historians. By the way, kid number 1 is asleep and baby number 1 is also asleep. I got a little bit more concentration time now. So part 2. Fortunately, the elves are trying to order so much fans that they qualify for a bulk discount. Under the bulk discount, instead of using the parameter to calculate the price, you need to use the number of sites each region has. Each straight section of fence counts as a site, regardless of how long it is. Consider this example again. The region containing type A plants has 4 sites, as does each of the regions containing plants of B, D, and E. However, the more complex region containing the plants of type C has 8 sites. Using the new method of calculating the per region price by multiplying the region's area by its number of sites, region A and E have prices 16, 16, 32, 4 and 12 respectively, for a total of 80. The second example above, full of type X and 0 plants, would have a total price of 436. Here's a map that includes E-shaped region full of E plants. That's an E. My kid is slightly waking up again, my baby. And the E-shaped region has an area of 17 and 12 sites for a price of 204, including the 2 regions full of type X plants. This map has a total price of 236. This map has a total price of 368, the AABBB. It includes 2 regions full of type B plants, each with 4 sites, and a single region full of type A plants with 4 sites on the outside and 8 more sites on the inside. A total of 12 sites. Okay, I need to get the baby, he's making strange sounds. Okay, so my baby figured out how to make bubbles with his mouth. Okay, where was I? Be especially careful when counting the fence around regions like the one full of type A plants. In particular, each section of fence has an inside and an outside, so the fence does not connect across the middle of the region, where the 2 B regions touch diagonally. The elves would have used the Mobius fencing company instead, but their contract terms were too one-sided. The large example from before now has the following updated prices. So 12.10. What was it before? 12.18. Oh. Okay, I think I know of a way to do this. But first, this one needs to sleep again. Adding those together produces its new total price of 1,206. What is the total price of fencing all regions on your map? He will take over. Okay, so for part 2, okay, so I will basically do the same as part 1, but I'll create a new function called measure land bulk. Inside the new function, save the fence positions instead, and create a vector 3i and use the extra number for the direction. So 0 will be horizontal and 1 will be vertical. So yeah, let's get to coding. Well, someone doesn't stop with crying, so yeah, I I don't think I can continue right now. Also, I'm kind of stuck with my solution. The plan that I came up with did not really, like, it's cool to have, but it would require way too much code, and I don't have the concentration capacity right now, so... Yes, it's your fault. He's silent. Oh. Okay, and I got the test data to work. This is really not the cleanest solution that you'll ever see, but it works. So first of all, I basically add all the fences into separate arrays. So the up, the down, the left, and the right. Then the same function as in the other one in measure land, but this is measure land bulk. So every time we come across a fence, we add it to the correct array. And yeah, then basically we have a lot of like bools and booleans. We go through y, we go through x, but for up and down and left and right, we basically switch the x and y because it's a square anyway, so we can do that. And for the range, we check -1 and we add +1 to the a ground size because we need to check for the outer border as well if that's also included or not. So yeah, and then we just check. I have a print statement here. I'll quickly undo this. Okay, so when I run this, this gives 1206, which is exactly the same as this here. I have to hurry, I only have 5 minutes left for reaching my 2-hour mark. I don't want to go over 2 hours. I need some time for the kids, so yeah. If you take the normal data, I think this should work. It's really not a clean solution, but honestly, it works and I can't be bothered. Okay, this takes a little bit of time. Okay, so this should be correct, and I will just say, voila, it works. Yes. Okay, well, day 12 done. I was really about to give up and until I discovered, like, wait, I can just put them in separate arrays and go from there. Thank you all for watching. A big thank you to my Ko-fi supporters. Cousin Alpha is being worked on and I'm getting very close. It's so exciting, but it's also like, yeah, life is kind of busy, especially by doing Advent of Code, but I hope to be releasing the next alpha this year. Anyway, thanks for watching, and I'll see you all tomorrow for day 13. I'll be quite busy tomorrow, so I'm not certain if I'll be able to do it on the day itself, but let's see.